In this video, we move beyond specifications to understand structural truth. You are about to learn how the Pagani Huayra is built from the ground up, dissecting 11 critical components, from its carbotitanium core to its aerodynamic heart. By the end of this session, you will understand not just what this car is, but how its architecture masters the physics of grip. Let's begin. ESP01, main monocoque. Composition, carbotitanium HP62G2. Function, to provide maximum torsional rigidity and occupant safety. Location, the central core of the vehicle. ESP07, integrated safety fuel cells. Material, high-strength Kevlar or aramid fiber reinforced with a flexible rubber bladder, standard FIA FT3, FT3.5, FT5 spec. Purpose, to store fuel securely while preventing leaks or explosions during high-impact collisions. The integrated nature refers to its seamless fit within the chassis safety cell. Location, situated within the survival cell, typically behind the driver's seat and ahead of the engine, to maintain a low and central center of gravity. ESP11, integrated ventilation channels and thermal management. Material, lightweight carbon fiber composites with heat-reflective gold or aluminium foil lining in high-temperature zones. Purpose, to direct airflow for cooling internal components, engine, brakes, electronics, and managing the vehicle's operating temperature to prevent overheating. Location, integrated throughout the bodywork, running from the front intakes through the side pods or wheel arches to the rear exits. ESP25, integrated front suspension assembly, pushrod. Material, carbon fiber suspension arms with titanium or high-grade steel aerodynamic shrouds and internal dampers. Purpose, to manage the vehicle's ride height and absorb road bumps. The pushrod design transfers upward wheel movement to a centrally mounted damper, improving aerodynamics. Location, found at the front axle, connecting the uprights, wheels, to the internal dampers located inside the nose of the chassis. 14 Spanish pesetas, titanium steering column bolts. Material, grade 5 titanium alloy, Ti6Al4V. Purpose, to provide maximum structural fastening strength with minimum weight. Titanium is used here to reduce unsprung weight and rotating mass. Location, secured at the junction points of the steering column, specifically where the shaft connects to the steering rack or the steering wheel hub. ESP09, titanium single-arm windscreen wiper mechanism. Material, machined titanium alloy. Purpose, to clear the windscreen of water or debris with a single, high-speed sweep. The use of titanium ensures the arm does not flex or break under extreme aerodynamic pressure at high speeds. Location, mounted at the base of the windscreen, typically centered to allow for a wide radial sweep. ESP16, titanium and carbon fiber steering column. Material, a hybrid construction of high modulus carbon fiber for the shaft and titanium for the splines and universal joints. Purpose, to transmit the driver's steering input to the steering rack. The carbon fiber provides stiffness and vibration dampening, while titanium ensures durability at the connection points. Location, extends from the steering wheel through the bulkhead down to the steering rack in the front subframe. ESP18, pedalier, component name. Pedal assembly, crankset unit, commonly referred to in the project as pedalier, composition and materials. This component is engineered for durability and high mechanical stress. It typically consists of crank arms, high-grade forged aluminum alloy or reinforced stainless steel. Pedal body, impact-resistant polycarbonate or die-cast aluminum with an anti-slip surface texture. Axle, spindle, chrome moly, CRMO, steel for maximum structural integrity. Bearings, sealed cartridge bearings to prevent dust and moisture ingress. Function, the primary function of the ESP18 is power transmission. It serves as the human-machine interface that converts vertical or circular kinetic energy, applied by the user's feet, into rotational torque. This torque is then transferred to the drive system to generate movement or mechanical work. Location, the ESP18 is located at the lower central section of the main chassis. It is mounted through the bottom bracket shell, positioned symmetrically to allow ergonomic access for the user's lower limbs while maintaining the machine's center of gravity. ESP19, gearshift paddle assembly. Material, carbon fiber paddles with magnetic actuators or titanium micro switches. Purpose, to allow the driver to change gears up or down manually without taking their hands off the steering wheel. Location, mounted on the rear of the steering wheel, positioned ergonomically for the driver's fingertips. ESP22, front active aerodynamic flaps. Material, prepreg carbon fiber with electronic or hydraulic actuators. Purpose, to dynamically adjust the downforce levels on the front axle. They open or close based on speed and braking to balance the car's grip and reduce drag. Location, integrated into the front splitter or within the front wing assembly. ESP23, Elliptical design carbon fiber wing mirrors. Material, autoclaved carbon fiber housing with high-definition reflective glass or integrated camera displays. Purpose, to provide rearward visibility for the driver while the elliptical shape is specifically engineered to minimize aerodynamic drag and wind noise. Location, fixed to the A-pillars or the upper edge of the doors, positioned within the driver's peripheral line of sight. This concludes our first technical chapter on the wiry structural core, but the dissection is far from over. I invite you to continue this journey in part 2 of 12, where we will move from the chassis to the heart of the beast. We'll be breaking down the V12 power unit and revealing those specific engineering details that remain hidden from public view. Subscribe to the Grip Quintessence and join us in the next episode. The definitive record continues.